everybody. I hope you are all well. So, today we are going to be going over the final lesson in our chapters 4 and 5 kind of combo that we're doing. This means that you are going to be having a quiz the next time we quote unquote meet. So, that means next week. You are going to be reviewing. So, I'm going to probably give you guys a Kahoot, and then you are going to be taking your test. So this is the time to ask questions. And now with the new telecommunication, virtual learning office hours that we're doing, that is the perfect time to ask questions. So please, if you don't understand any of this or don't understand a little bit of it, come to the office hours and I will try my best to help you. Okay. So Newton's third law of motion, we are wrapping up Newton's laws. So the first law, if you remember, was an object in motion will stay in motion unless acted upon by a force, an outside force. The second law of motion was F equals ma. And Newton's third law of motion, for every action, there is an equal but opposite reaction. So here we have a picture of two boxers, and the guy on the right is punching the guy on the left. So the action is the fist that is exerting force on the jaw, the actual punch. That is the action. But you don't really think about the reaction in this case, but there is a reaction, and that reaction has an equal force. So the reaction is the jaw exerting force on the guy's fist. That's the whole reason why they wear boxing gloves in the first place. If there was no reaction to every action, you wouldn't need to wear boxing gloves because your hands would be completely safe. A lot of people wear boxing gloves so they can protect their fists, protect their hands and the bones in their hand. So the reaction of the jaw pressing on the guy's fist is actually just as powerful as the punch itself. So for every action, there's an equal but opposite reaction. Can you guys think of any examples? Let you mull it over for a second. Alrighty. So I'm going to be posting this video for you to watch. I'm not going to play it now because the audio won't pick up on my screencast, but after you watch it, I want you to think, what is the action that's happening and what is the reaction? And if you have the materials, you could actually do this at home. It's a really fun activity. Okay. Now, these two objects next to each other are kind of funny, but they do serve a purpose. So the mass of an object and how fast it's moving, so basically the bulk of it and how fast it's moving, its speed, can determine how easy or difficult it is to stop that object. So what do you guys think? Do you think it's easier to stop a smart car while it's moving or an 18-wheel truck? If you said the smart car, you would be correct. It is smaller, it has less mass than the 18-wheel truck, so it's obviously going to be easier to stop. So if we were in class, I would do a demo with you guys. I would have one person come up to the front of the room, and I would have them walk toward me with my hand outstretched, and I would try to stop you from walking. It would be very easy to stop you from walking because you're not moving very fast, you're moving quite slow. Then I would have two of you come up. I would have one person stand with their hand outstretched just like mine, and then I would have the other person run toward that outstretched hand. You guys would see and surmise from the demo that it would be harder to stop someone running than it is to stop someone walking because they're going faster, they're moving at a higher speed. So momentum is something that we're going to be actually calculating today. That's going to be your assignment for today. And momentum is basically how much force is needed to change the motion of an object, to stop it, to make it go faster, to change its direction. So it is the quantity of force that's needed to change the motion of an object. And it is simply very easy formula, mass times velocity, or mv. And you could actually do the triangle that we did for F equals ma. It's the same exact triangle, the same exact one, except momentum is on top and mass and velocity are at the bottom. So if you guys want to write that down and use that for what we're going to be doing, that's totally fine. So P equals mv. Don't ask me why P is momentum. It's actually not a P. It's a Greek letter that looks like a P, but for us, we're going to be using P. And the unit for P, or for momentum, is kilograms times meter per second. So it's one of those derived units again, where you don't have just one unit, it's two. So this is an entire unit, kg dot m over s. So we're going to practice. So the question is, what is the momentum of a 100-kilogram car traveling at 15 meters per second? So we need two things. We need our mass and we need our velocity. So let's see if we have those things. Here we know that kg is mass, so we have our mass, it's 100. And we know meters per second is velocity, so we have our velocity. We have m and we have v. We need to find p, the momentum. So what are we going to do? Well, we're going to plug the m in here, and we're going to plug the v in here. So it will be 100 times 15. Try to do that in your head. Let's see if you got it right. It is 1,500 kilograms times meters per second, or 1,500, however you want to say it. This is our derived unit, okay? So this is our unit. That's what you put after your momentum. All right, that was a quick one. So remember, you're going to be having your quiz the next time we meet, which will be Monday, I believe, or Tuesday, depending on which class you're in, because I'm using this for all of my 8th graders. So it will be next week, but you will have time to study and to ask me any questions that you might have. All right, so let me know if you have any questions, email me, or attend the virtual office hours, and I would be super glad to help you. Have a good one.